Let's pan the camera so we're looking down in the hallway of this building. And we have two surfaces that are parallel. And if you just took the building, the hallway out, and you had a bird's eye view and you're looking down, this could be a crack in a granite wall. So now we're thinking, okay, this could be where I was going to place an SLCD, Camelot, Friends, whatever you want to call them. And you place it in this crack, and the lobes expand as you pull out, and it creates this force in both directions, outward force against these two surfaces that really they have to be in parallel. It doesn't really work if they are offset, and that secures your anchor in place. And this is no different. So a jam pole is basically recreational rock climbing pro, but for the industrial environment on like a bigger scale. So a jam pole is an anchor. We can take a stick, a 2x4, a piece of lumber. Here we're using the vortex, and we're trying to size it up so that we need to know our direction of pull. In this case, our MPD's operating device, so our direction of pull is straight this way. And since it's straight this way, I need to orient this pole so that it'll effectively cam more. The more that this is loaded, the more it cams, and the stronger our system becomes. That implies that I can't have this Maestro, or sorry, the MPD or the descent control device or the multi-purpose device. If this were anchored further up here and then we pulled this way, it just seems common sense that this is just gonna, it's not gonna anchor itself in, it's just gonna fall out and we don't have an anchor. So we have to angle this so that our direction of pull will create force that's bringing this part of the pole up and squeezing against this surface and creating this outward pressure against this surface and putting this one back. So this whole thing is twisting and torquing on itself and securing itself in place. That's the fundamental concept. These are just to keep it in place while we're rigging it. You can imagine if this was elevated off the ground, we would need to secure this in some way. Right now it's pretty self-explanatory, it's easy, it's on the ground, there's not much we need to do, but we can lash the forward member here back, and follow me back. And it's just how creative you want to get with the rigging. And here, webbing is a little bit better than cordage. If we want to encapsulate the door hinge that you can't see right here, we encapsulate that, then we shut the door, and then we establish a trucker's hitch to just lash everything securely in place. And just to add some layers of complexity to this, we decided that our load's actually over there through another opening. And our simulated load is just a weight. And so now it's not really an anchor frame, this is a directional frame jam pole. And so we have to account for what the resultant force really looks like here. So if we look and we pull here, okay, so our resultant force is not quite straight on this wall, but it's kind of coming in a little bit. And that's something to consider, because the more your resultant goes away from straight down this wall, or this side of the wall, and starts to go in this way, you kind of get to lose the effectiveness of your jamming mechanism. But it'll still work in this application because our resultant, our angle is pretty narrow, it's tight, and so our resultant still is pretty close to the wall. Over there we used a vortex on the anchor frame. Here on the directional frame we're using the Paratech Strut. What's great about the Paratech Strut is that you can size this pretty well to fit some spaces that you couldn't with the vortex. With the vortex, you have these set pinholes, and sometimes it's not conducive to get you like the right kind of offset angle here. But with the Strut on these Acme threads, like you can pretty much get the angle we were looking for here, which is kind of like your 10 to 15 degrees. So if you pan the camera top down on this Strut, perpendicular distance between these two surfaces, and if you offset that by about 10 to 15 degrees, that's kind of the range where we want to be as far as optimizing the forces that are going to be able to push against the two surfaces to lock our anchor in place. If we're straight on, there's no guarantee that it would be effective. It would just pop out. And also, if we were too much of an angle this way, it would just kick the opposite leg forward and we wouldn't have our anchor. So we want to be in this nice 10 to 15 degree kind of offset angle to make this work for us. We have options with the Paratech Strut. Either way, I want to use swivel bases on one, but on the other one, I could easily put this little guy here, but then I need some sort of prusik, webbing, whatever, to start hooking up my attachment points. Or I could just cheat and use one of the extrication base plates that has an integrated anchor plate here, where I can just hook as many things as I need to right here. So we have our directional, and then we also basically collapse the two jam poles together with an Aztec and really like sucked them together. So now that like we're kind of reinforcing effectiveness and security of our anchor. What we did here was we lashed again through the door frame on the hinge, back on itself, and then choked up and just secured this in place from slipping out that way. I don't want to get too far outside the scope of rope rescue, but you could possibly reinforce, instead of putting these base plates directly against the wall, you could put lumber and extend it out, and that lumber would dissipate the forces against the studs that are behind the wall. This jam pole is a vertical jam pole. We had to get creative. There's a lot of things going on here, so if you want to zoom in. This is just a girder we had to place here, because if you look up in our station, like, we can't anchor anything up there. That's not structural. So we need to create some sort of artificial structural ceiling. And this isn't part of doing jam poles, but it's probably worth mentioning that it's an option, right? We take a 6x6 kind of girder. We wanted to set it in place so we go hands-free and rig in our jam pole. And in order to do that, we decided that we would take more Paratech struts with these specialized brackets and basically put our girder in position and then launch our struts up, secure them in place. And then also, if you look at the cross section, we have two doorways here. These are headers. We're going to deem that they're structural. They're support members up top. If we were concerned about this girder moving, it's butt up against the frame of the door, but here it's out in mid-space, and so if we were concerned about our girder moving fore and aft, we could always just account for that by what we did here. We just tied this back. Again, just using hinges on a closed door with webbing as an anchor point. So that would keep our girder from going forward. If we wanted to keep it from going back this way, we didn't feel like there was a need, but we could also just rig something else here and then tie something back to anything we found on the inside. We're doing non-destructive rigging, but in reality, we could drill holes, we could pound hammers in. We just don't want to destroy our station. Enough about the girder. Let's go back to the jam pole. Again, vertical, straight up and down. We're offset out about like 10 to 15 degrees max. And we don't want to operate our device high, because if we pull that direction, this thing isn't an effective jam pole. It's just going to fall over. So therefore, we're going to operate our device low on the ground here. And so whether we're hauling or lowering, our force vector, our resultant, or our alignment, everything is pulling this base plate in this direction. And as this is pulled in this direction, I don't need any back ties here because I don't want them there. I want this to actually jam more this way, and as it jams more this way, it pushes down and up on both sides, and it pushes up against the girder up here, and it becomes more secure. So again, just like rock climbing, active camming, right? Active camming on the Tricam or the active camming on the lobes of an SLCD, kind of the same concept. And since our girder is only like 5.5 inches by 5.5 inches, and our base plate is sitting right there, we just square lashed the upper base plate just to keep it set. So this is our line, our loaded line. This represents our load, our rescue package. And again, we're doing this in a horizontal orientation. This could be anything. We could be standing over here, and the sky would be this way, and everything would be oriented, and our frame of perspective would be different. You just have to use your imagination. We aren't confined to like a hallway in a fire station. So at face value, it looks a little complicated because of all the guying and the lashing and the securing we had to do. You could call this frame, it's a directional frame, as you can see right here, directional. Our resultant forces, it wants to pull this head and this pulley back down through this doorway. So before we had a jam pole, we could get away with that because the loaded line, the origin of this loaded line on that jam pole was way down this way, which meant that we could get away with putting a jam pole in here and being comfortable that it would jam effectively and provide that camming opposing lobe action. When our loaded line is not at that acute angle and it's fanned out more like a 90-degree bend, putting a jam pole anywhere in here kind of doesn't work as well. Just based on the resultant forces. But what will work is if we can rig some sort of a frame using our vortex, and we just have to stabilize the frame so it doesn't fall I wanted to elevate it somewhere around like thigh height, which made even more of a challenge because now not only do I have to kind of secure this frame this way to whatever structural components, I have to keep these legs from falling down on the ground. It's pretty easy with the head because this is basically like an easel leg. So if you look, so if I take the camera, and right now everything's straight up and down, but if I turn the camera this way, and if we assume that now this is the ground and the sky is this way, this looks kind of like your easel leg or lazy leg sideways A-frame. So a lot of these frames have different names, and it's just based off of kind of your perspective. So let's look at the feet. We had to secure the feet in place by guying one direction, but when we guy in one direction, we pull the legs apart, so we want to bring it back and to keep it from mousetrapping over. And so that's when we tie it. This prusik right here, initially we thought maybe we would hobble the legs together, but if we did that, we would basically create an obstruction across our space. And we needed to figure out a different way to secure the feet. So we just created an anchor way out there into the kitchen. That could be a big boulder or a rock. And we use that, and then we dual purpose, not only securing the foot in the other direction, but also securing the head and sucking the head down and putting pressure on our compression members to get the frame pressed into the side of the wall. Same thing on the other side. And some of like the basic principles of guying and securing artificial high directionals, which this isn't a high directional, it's a directional, but it's not high, are securing the legs, securing the head, and then accounting for that resultant force. We've accounted for the resultant force. We've independently secured the legs, lashed, hobbled, whatever you want to call it. And then up on the head, we've secured the head with the 2 yellow pieces of webbing, tying this thing down, bringing the whole frame from the head down into the compression members to make it more structurally stable, as well as tying the upper portion back. These don't really provide any force that's driving this frame into that sidewall. This just helps keep it stable laterally. Overly elaborate? Sure, yeah. I mean, sometimes you have to think outside the box on rigging solutions that don't exist anywhere, and you have to make it work, or you have to create something where there's seemingly nothing to actually rig to.